What I'd like to do today is just spend a minute or two reviewing a practice problem, a really simple problem, to give you an intuitive feel of how to walk your way through these truss and frame problems. What I've done here is I've drawn a very simple truss, as in not complicated, simple truss with a couple forces, and our goal is to work our way through and identify what all the forces are in the members. I'm going to use red for areas where we've already figured things out. The two really great tools that we have are the same as the tools we've been using the whole time, and that is the sum of the forces about any point is equal to 0, and the sum of the moments or torques about any moment, about any time, about any point, sorry, equals 0. Now that said, let's start off with finding out the reactions at the supports. The best way to do this, especially as there's almost always two supports, is to sum the moments. The question is, which one are you going to sum the moment about? Well, let's look at what we know. We know that at A, we have a force in this direction. Well, let's keep our x and y axes just like this. X, y. We have a force and another force, possibly. Because it's fixed, we don't know the direction or the magnitude of the force. However, at B, we know the direction. We simply need to know the magnitude. That's one less unknown to figure out. So let's look at the torque about A, because then all we'll care about is what's happening, the force at B. So we'll use the torque about A. We have, and for helping you out, let's say they're equilateral triangles. Each one is 8 feet long. It makes it really simple. We know that there's going to be a torque due to this force, a torque due to this force, and counteracting it is going to be a torque due to the force at B. So we can use the sum of the torques about A. We can use that to figure out the force at B. Now what? Well, now take a look at our diagram. We know what's going on at B in the vertical direction, so we can use that to figure out what's going on in A in the vertical direction. So in that case, we're going to take the sum of the forces in the y direction equal to 0, and that is going to lead us to force A in the y direction. Now we need to figure out the force of A in the x direction. It's a little tricky, so let's take a look at what we know. We know that the sum of everything is moving in the horizontal direction. We also know that the moment, or the sum of all the forces, is going to be 0. That's not really going to help us too much here, but what we do know is that the entire, if we choose our free body diagram to include the entire system, it all can't rotate. And the way it stands right now, let's imagine you're at this point. You pivot the whole thing about that point. Well, you have forces on this side wanting to make it rotate counterclockwise, forces on this side making it want to rotate counterclockwise. So this whole thing wants to rotate. Well, the only thing keeping it from doing that is this force right here. So the next thing that we can do is let's sum the torques about B and set those equal to 0. Well, that's going to mean that this torque right here is going to fight everything from rotating. So we will find all of force A. There we go. So we're making it through. We found force A, we found force B. Now let's keep on moving through. Let's draw a free body diagram at A. That seems to be where we know some things. We have the force of A. And then we have, in addition, these are unknown, so let's keep them unknown. In addition, we have the force in the AC member. And then we have the force in the AB member. Well, we know that the sum of all these is going to go to 0, right? Well, in the x direction, we're a little confused because we know this one right here, but we don't know either of these. But in the y direction, we have a vertical force A. Well, if we know that, we know exactly what the vertical and the force B is. And if we know the vertical and the force B, we know the horizontal because we know the direction. So therefore, we figured out what force B is, and if we know that, we now have the horizontal here, one unknown, force AC. So we can figure out what force AC is. So now we're extending our reach, we're broadening our reach. We know what the forces in these members are. The next place we go is, quite frankly, really up to you. Well, actually, I'm doing the video, so I guess it's up to me. Let's go to C. Once again, we draw a free body diagram and see what we know. We have 1,000 pounds coming down. We have force CD. We have force BC. And our known is this one right here. Oh, actually, we know 1,000 pounds, right? Now, we can, if we want to, we can set up simultaneous equations here because there's no way to do this in just one equation the way it's set up right now. So we could set up simultaneous equations. My instinct is to look at this and say, well, let's hold on C for right now and instead go down to B. We can do it, but I'm looking for the easiest way to do this because I got a lot of work. So at B, horizontal. There we go. This is force BD, force BC, and then we have force AB, and then this, force B. Now here we have good news. Check this out. We have horizontal. We can't do sum it to 0 horizontally, or it'll just be tricky because we have this unknown and this unknown. However, let's say vertically what's happening. Well, vertically we have the force of B and we have the force of AB. We can figure out what the vertical component is, and that from there we can figure out the vertical component of BC. And once again, if we know the vertical component, we can figure out the horizontal component of BC because we know the direction. Now we have the horizontal member component of BC, so we can find out the horizontal of BD. So now we've moved to here. Well, let's take that back to our free body diagram at point C. We now know the force of BC. We can easily figure out the force of CD. And you can do that by summing in the X direction, summing in the Y direction. It just doesn't matter. So now we're moving all the way down. And if we want to do a check, we could always find out, do a free body diagram about D and make sure that everything adds up to what it should be. So hopefully that gives you a little bit of a feel using, in this case we use a method of joints to chase our way around a strut to find the solution. I'm going to float this one out there, and if you have any requests for more sample problems to get a better feel of how to navigate your way through these, by all means send a request or some sample problems and I'll show you how to do them. Thanks, and we'll see you on our next module.